Okay, welcome to lesson 16, which is going to be about absolute value equations and inequalities. So as you can see, I'm going to attempt to kind of narrate our way through this PowerPoint, and I'm going to try to actually take notes right on it. So hopefully this is a little easier for you to see than me writing on the board. So let's give it a try. Okay, in our last lesson, we talked about compound inequalities, and we will get to inequalities, but we actually start off with equations with equal signs. So let's take a look at the type of equations we're going to see. Let's see here. Absolute value equations. Okay, so remember absolute value is going to be distance from zero on a number line, and it's always positive. So here's some really basic examples that you've seen before with absolute value. The absolute value of 5 is 5. And the absolute value of -5 is also 5. Okay, so if we were to do a quick sketch on a number line, might look like this. Here's 0. And then 5 is 5 units away from 0, and so is -5. Both of them have that distance of 5 units away. Okay, and the direction doesn't matter for distance. So the distance, it's kind of like 5 miles away from you to the east or 5 miles away to the west. Both of them are 5. Okay, so if I were to ask you which number has an absolute value of 5, for example, maybe you'd see this equation. What is the number x where the absolute value of 5 is 5? Excuse me. There's two answers. Okay, that's going to kind of be the main idea of these absolute value equations. Two answers. 5 or -5. Those are the two different possibilities for what x could be. So here's where we get to our main idea for how to solve absolute value equations. If you have the absolute value of x equal to a positive number, then one of two things could happen. X could equal that positive number, or x could equal the opposite of that positive number, meaning negative, right? So if the absolute value of x is equal to 5, x could be 5, or x could be -5, okay? X could be p, positive, or x could be -p, the opposite of p. Okay, there's a couple of little extra kind of exceptions or other things to keep track of here. If the absolute value of x is 0, there's only one answer to that. Okay, so if your absolute value is 0, that means you're literally at 0. There's not going to be two answers to that, positive 0 and -0. It's just 0. And then one additional thing to keep track of, if your absolute value is equal to a negative, that does not make sense. Okay, that equation will have no solution. Now, I know you might be thinking, wait a second, didn't you just say -5 could be a solution? Yes, I did. A negative can be a solution to an absolute value equation, but the absolute value itself can't be negative. So here's what I mean by that. Just gonna try to clarify this. So if you have, let's say the absolute value of x is equal to, let's say 5 again, x could be 5 or x could be -5. We got that. What I'm saying over here is if the absolute value was said to be equal to a negative, that doesn't make sense, okay? Absolute value is distance. Distance cannot be negative. Location on a number line can be negative over here, but distance cannot. Okay, so we're going to go to the next slide now and see some examples. Okay, oh, and I gotta erase all this. Erase. All right, let's actually solve some equations here. All right, so you can see some steps that are written up at the top here. First, you're going to, let's see, move this out of the way here. You're going to isolate the absolute value. So the thing you're getting by itself first, let me just clear this, clear all drawings, there we go. The thing you're going to isolate or get by itself first is the absolute value. So in all three of these examples, that's already been done for us, but we'll see sometimes there's extra steps to make that happen. So the absolute value needs to be isolated by itself first. Okay, in this particular set of examples, that's already done. So here's the thing you really want to pay attention to. You're going to split the problem into two separate equations. The most common mistake when students solve these problems is they only give one answer. Expect to give two answers for the most part, okay? So x could be p, positive answer, or x could be a negative answer. You can see how I wrote the negative first here. It doesn't really matter, but when we get to inequalities, order will matter more. So I'm going to try to start actually getting in the habit of writing the negative possibility first and then the positive possibility. And that'll become a little more clear in a minute here. And then this third, not exactly a step, but kind of a third note, if the absolute value is equal to a negative number, we saw that earlier, then the equation has no solution. Okay, so let's actually solve these. Okay, number one, the absolute value of x is equal to 8. So what could x be? Now, x could be 8, right? The absolute value of 8 is 8. That makes sense. X could also be the opposite of 8, negative 8, because the absolute value of negative 8 is also 8. So here are my two possibilities. X could be negative 8, or x could be positive 8. Those are my two possible solutions. Why do they work? Well, let's check. If you take the absolute value of negative 8, remember absolute value is always positive. The distance from negative 8 to 0 is 8. Now let's check our other answer. The absolute value of 8, how far away is it from 0? Still 8, okay? So both of those solutions work. So there are two solutions for these equations. That is kind of strange, right? You're used to getting just one answer for x, okay? So the way we would write our answer is sometimes in a solution set with these squiggly brackets, and you just list both answers with a comma in between. That's the main idea. So notice how we had the absolute value isolated already. Then we split the problem into two separate equations. X was equal to negative 8 or x was equal to positive 8. Okay, and then we had our two solutions. Okay, the third little note here didn't apply to this problem. Okay, let's go on to number 2. The absolute value of x is equal to 0. Okay, on the previous slide, we actually saw if this is the case, then you have actually just one answer. X is equal to 0 is your only answer. But if you forgot that, you could technically split it up into two equations. X is equal to negative 0 or x is equal to 0. But the thing is, negative 0, what is that? That's just 0, okay? So really there's just one answer. That's meant to be a question mark, there you go. There's really just one answer. So in our solution set for this, you would just have 0. That is really the only answer here. Usually these equations have two solutions, but this is kind of the exception. If the absolute value is equal to 0, that means your distance is 0. So you're just right there, right at that center of the number line. Okay. Number 3, here we go. The absolute value of x is equal to negative 3. Now you might instinctively start to split it up into two problems, except hang on a second. This can't happen. The absolute value could never equal a negative. This is that third note right here. Okay, absolute value will never be negative. Okay, earlier in number 1, x could be negative. That was fine. That was okay. But the absolute value had to be positive right here. Okay. The problem with number 3 is that we're trying to solve a problem where distance is negative, and that doesn't make sense. So there's actually no solution here. Okay, so we would say distance cannot be negative. That's kind of the reason. But what we would say is there's no solution. Okay, so those are 3 kind of simple examples, or short examples, I should say, of absolute value equations. Most problems that you will see are like number 1. Okay, this is kind of the classic common example here, where you split the problem into 2 and you end up getting 2 solutions. Sometimes the absolute value is equal to 0. That's not very common, but if it happens, your answer is 0. And then number 3, you know, that can happen as well. Absolute value could equal a negative. or excuse me, your problem could be set up where absolute value is equal to a negative. But as we just said, actually it can't. So that's why we would say no solution for that one. Okay, good. So let's move on to some slightly more complicated problems here. Okay, next slide. Here we go. All right. So we're still going to follow the same types of steps when we solve these. But as you can see, it's not just x in the absolute value. There's more going on now. Okay, so here's what we're going to do. We still want to make sure that the absolute value is isolated, which it is. The absolute value is all by itself on the left side here in number 4. So we can go ahead and split this up into 2 problems. Now our 2 problems, if this was just the absolute value of x, we would say x could be equal to -9 or x could be equal to +9. We're just going to do that with 2x minus 7 instead. So 2x minus 7 could equal -9, or 2x minus 7 could equal +9. Those are my 2 possibilities. Now we're going to solve each one. We have 2 different equations. We're going to solve each equation and we'll end up with 2 different answers. You should know how to solve these by now, okay? You just finished a unit on that included solving equations. You've solved equations much harder than these. So still use the same skills that you've been working on, getting x by itself. Okay, so for this equation over here on the left, I'm going to add 7 to both sides. -9 plus 7 would be -2. Then I'll divide by 2. And x is equal to -1. So one of my answers is -1. Now I'll go over to the other side and solve for x over here. I'm still going to add 7 to both sides. 9 plus 7 is 16. Divide by 2. And x is equal to 8. So those are my 2 solutions. They're not, it's not like +8 and -8 or +1 and -1. They're totally different numbers because this is a much more complicated problem than the previous ones. So you might get one negative and one positive, or you might get both positive or both negative. There's really not necessarily a pattern. The main idea that I want you to get from this problem is, how did we start it? We started it by setting it up as 2 different equations, number 1 over here and number 2 over here. And that resulted in 2 different answers, -1 and +8. And as we did before, we can write our answer using a solution set, -1 and +8 in those little squiggly brackets. Okay, good. Let's look at number 5 next. This time we do need to isolate the absolute value first. That's this right here. We need to get it by itself. Okay, how are we going to do that? Well, I need to get rid of this +2. So we're going to subtract 2 on both sides. Notice I have not split up the problem yet. I am not ready to do that. If you did split it up, maybe you set it equal to -14 and +14, you would not be correct, okay? So you'd still get 2 answers. One of them would be wrong. Okay, it's too soon to do that. You don't split up the problem until the absolute value is all by itself. So that's what we're trying to do first here. Okay, so I subtracted 2 on both sides. There's no more +2. And now I have 14 minus 2 is 12. Now I'm ready to split up. Okay, so I'm going to split up the problem into 2. One possibility is that the expression inside the absolute value is equal to -12. And then the other side, the other possibility is the expression could equal +12. Those are my 2 possibilities. Okay, let me edit that a little bit. Sorry, a little bit messy. Okay, let me fix that actually. Sorry about that. All right, and then you have 2 equations that you can solve. X plus 5 is equal to -12, or x plus 5 is equal to +12. So with both of those, you can solve by subtracting 5 on both sides. So x could be -17, or over here, 12 minus 5 is 7. So it looks like we're getting -17 and +7 for our possible answers. So again, we have 2 answers to this absolute value equation. Okay. Good, let's move on. All right. So we have a few more here. These will also require us to isolate the absolute value. So let's start with number 6. Okay, so right here, the absolute value of 3x is what we want to isolate. Okay, so we need to start by getting rid of this 9. So let's subtract 9 on both sides. Okay, what we're left with is this minus sign, which we need to keep here. That didn't go away. It is in front of the absolute value. It's not inside, it's in front. So it's kind of like a -1 coefficient. In other words, this expression is being multiplied by -1. So we'll have to get rid of that as well. Let's just simplify on the right over here. Okay, so we're working on isolating the absolute value. Now you might notice that it's equal to -6, but don't worry, because here's what we're about to do next. Think of this minus sign as kind of like a -1 or -1. We actually want to continue isolating the absolute value by dividing by that -1. Okay, so now we finally got it by itself. The absolute value of 3x is now just equal to +6. Negative divided by negative is positive. Now we're good to go. So now we can split it up into 2 problems. Okay, and by the way, notice that when we split up the problems, when we split the problem up into 2 equations, we no longer have the absolute value. Okay, so as I'm writing my 2 equations, there's no absolute value. So 3x, the expression inside the absolute value, could be equal to -6, or 3x could be equal to +6. Those are the 2 possibilities that would work. And in this example, both of those equations can be solved by dividing by 3. Okay, so it looks like we're getting -2 and +2 for our answers. So my solution set would be -2 and +2 for that one. All right, good. Let's take a look at number 7. All right. Okay, good. So let's look at number 7. Let's see, we want to isolate the absolute value. So you can see, by the way, the 6 is not inside the absolute value here. So just notice that. That'll maybe be relevant in a minute here. But we want to start to isolate the absolute value by getting rid of this +10. So let's start with that. So we'll subtract 10 on both sides. Okay, 4 minus 10 is -6. Then we'll bring down what we still have, 6 times the absolute value of x. Okay, remember last time how we divided by -1 on both sides? What we're about to do now is divide by this 6. Okay, so what do we have left? The absolute value of x is now by itself. That's good. On the right side, -6 divided by 6 is -1. Okay, so we have isolated the absolute value. We got it by itself, but look what we have here. We can actually stop right now, and here's why. The absolute value is equal to a negative, so that can't happen. So there's actually no solution to this problem. Okay, if you're thinking, oh, well, could it be 1 or -1? If you plugged in a 1 here, the absolute value of 1 is just 1, not -1. If you plugged in a -1 for x, still, the absolute value of -1, it would be +1. Nothing's going to give you a negative answer here, so there's no solution. Okay, so you can write that circle with a slash through it. You can just select the no solution choice on your homework. Sometimes you see it as this empty set. Okay, as soon as you get to an absolute value expression equal to a negative, stop right there. That's impossible, not going to happen. So no solution to that one. Okay, good. Okay, so that's kind of the first half of this section. on absolute value equations and inequalities. So we are now going to kind of move to that second part, which is going to be on inequalities. Okay, now we've talked about inequalities quite a bit already in this class. Lesson 14 was about inequalities. Lesson 15, we did compound inequalities. We're now going to see more compound inequalities. That's kind of what we're going to see here with absolute value. Okay, so here are the 4 different types we will see. There's in a way, there's kind of 2 types actually. So let me kind of highlight that for you. When you have absolute value less than or equal to a number, think about it as your distance is less than something. So you are close to 0. Let me type that out for you. So close to 0. Let's see, how do I want to say that? Distance is less than something. So you're going to be close to 0 and between your endpoints. That's the main idea here. Okay, thank you. Sorry about that. Okay, sorry, I'm going to pause my recording here. Okay, sorry about that. A little bit of distractions happening, but I think we took care of it. Okay, so we're talking about 4 types of absolute value inequalities. The note that I just wrote you here kind of applies to the first 2. Anytime you have a less than or a less than or equal to sign, remember absolute value is distance. If your distance is less than something, distance from 0, less than a certain number, you are close to 0. So your inequality, you're going to be shading close to 0 in between 2 endpoints. So you can see in our set notation here, x is going to be between 2 endpoints. And your interval notation, that sounds familiar hopefully, your interval notation will be a comma b. It'll be one number, comma, and then another number. And that's the way that we represent shading in between 2 endpoints. Okay, so that's what we're going to do anytime you have less than. For less than or equal to, that just means you have these equal to signs, and that means your square brackets will be what you're using rather than parentheses. Okay, now for the last 2 types, these are maybe a little bit harder. So let's make some room to look at these here. Okay. All right, so for your greater than inequalities, it's sort of the opposite, okay? So rather than shading in between 2 endpoints, it's kind of everything except in between. So if you have these 2 endpoints, negative p and positive p, you're shading on either side of those, okay? So it's either x is less than negative p or x is greater than p. It's one or the other. So essentially you are far away from 0. So if your distance is greater than something, you are far away from 0. And you're going to be going in opposite directions. Okay, so your arrows, first of all, there will be arrows now going in opposite directions. Okay, so for these examples here, if your absolute value is greater than or equal to p, it's either x is less than or equal to something or x is greater than or equal to something. So the simplest example of this would be x is less than or equal to negative p or x is greater than or equal to positive p. And then this is what your interval will look like. It'll be 2 different intervals with that union symbol in between. We saw this in our previous lesson. Negative infinity to your first number a, and then union, and then b to infinity. So it's a much more complicated way of writing the answer. You're not shading in between the endpoints. You're doing the exact opposite of that. Okay, and you know these 2 different types are so similar that the main difference is which type of inequality you're using, whether it's equal to or not. And if it's equal to, you'll have the square brackets. If it's not equal to, you'll have your parentheses. Okay, let us take a look at some examples. But this is kind of the summary of the different types that we're going to see. Let's take a look at those different types. All right. Here we go. Okay, so we have our steps kind of summarized up here for solving absolute value inequalities. Okay, so first you want to isolate the absolute value. We've done that before. You will rewrite the problem as a compound inequality. So it's going to be one of these two situations. If you have less than, then you're going to go in between your endpoints. If you have greater than, then you'll go on the opposite sides of your endpoints. Okay, so I'm just going to write those words as just some reminders. Between is one, and then the second type we're going to say opposite. So less than is between, greater than will be opposite. Okay, now what does that look like? Let's go see. Here's number one. So the absolute value of x is less than 3. Before we just jump right in and answer this, I'd like to try to illustrate what's happening. Okay, so on a number line, here's 0. What are all the numbers that are less than 3 units away from 0? Let's write that out right here. Less than 3 away from 0. Okay, which numbers are less than 3 units away? Well, let's start with, how about 3? What can we say about 3? Now 3 is exactly 3 units away. So actually we don't want to include that. But something like 2 or 1 or 2.9, those are all less than 3 units away. What about on the other side? Over here to -3. Again, we're not including -3. -3 would be exactly equal to 3 units away from 0. We want things that are less than 3 units away. So let's shade what we mean by that. First of all, 0, that's less than 3 units away. 1, yep, everything in between. 2, yes, everything up to 3, but not including. So we're going to use parentheses here. Okay, and then all these numbers until we hit -3. Okay, so this is essentially my answer on the number line, and you can almost see what the interval is going to look like here as well. These are all the numbers that are less than 3 units away from 0. Their distance from 0 is less than 3. Okay, so here's how we would write this out. Okay, I'm essentially using this as a guideline. If the absolute value of x is less than a positive number p, which it is, then x is between, so x is between negative p, in this case -3, and positive p, or in this case +3. This is a way of illustrating the answer in set notation. In interval notation, what I would say is from -3 to 3, like that. And maybe I could also add that up here as well. Okay, so you'd write -p, comma, p, like that. Okay, so that's generally what it's going to be when you have less than. You're in between two endpoints. Now, it's not always going to be -3 and 3 or -5 and 5 or something. You might have to do some more operations, so it might end up being, I don't know, between 2 and 12 or some other types of numbers. But the point is you're going to be between two endpoints when your distance is less than something. Okay, let's take a look at another situation. Here's number 2. We're still using the number 3, by the way. Okay, what if we have almost the opposite situation? Here's 0, here's 3, here's -3. I want all the numbers whose distance from 0 is greater than or equal to 3. Let's write that out. Okay, so distance greater than or equal to. Okay, greater. I'm just going to make that super emphasized there. So we're looking for numbers that are farther away from 0. Their distance is greater. Greater than or equal to 3. Okay, so I want all the numbers who are more than 3 units away from 0. So kind of an analogy is, who lives more than 3 miles away from you on either side? Okay, it's not all your closest neighbors, it's farther away on one side and farther away on the other side. So let's sketch it on a number line here so we can get the idea. Now, whoever lives 3 miles away, that because of this equal sign, we are going to include that endpoint. So we'll include that in our answer, which means we are going to have square brackets by the time this is done. Nothing here, nothing in between 0 and 3. All those numbers are too close. We want our distance to be greater than or equal to 3, farther away from 0. So it's all these, and there's no limit to this. We need an arrow. We're going toward infinity. Okay, and now that I know which way I'm going with my arrow, I can do my square bracket. So that's everybody in the positive direction who's greater than or equal to 3 or farther away from 0, farther than 3 units away from 0. But what about the other side? We're going to have another arrow going this way as well. All these numbers are also greater than 3 units away from 0, farther away from 0. We're just going in the opposite direction, that's all, towards negative infinity. So see how we have 2 different intervals? There's 2 different parts to our answer, and they do not overlap. So good thing we know about interval notation. Here's how we would write our answer in interval notation. But let me first do the inequality. I almost forgot. Okay, so this is what we're looking at right here. Okay, so for this problem, if your absolute value is greater than a positive number p, then one of 2 things can be true. X could be less than negative p. Yes, less than. See how we're going to the left? We definitely need less than as part of our answer. Or X could be farther away in the other direction. X could be greater than positive p. It's one or the other. So that's, I know that's weird too. Okay, let's put it all together. So X could be less than or equal to negative 3, or X could be greater than or equal to positive 3. Okay, as an interval, negative infinity to negative 3 with the square bracket because of the equal sign. Union 3 to infinity. That is my nice long answer in interval notation. Okay, so the 2 problems on this slide, they both seem so short, and they are so short. There's almost nothing that we need to do to solve other than know which of these scenarios we're dealing with, and which one we're modeling after. So for this second one that we just looked at, the interval notation for this type, the greater than type, it's going to be negative infinity to negative p, union p to infinity. That's kind of the main idea, and p could be a different number depending on the problem. Okay. Oh, how I wish I could ask you in class, do you have any questions? Because you just might right now. So maybe now's a good time to pause the video and really just get it all down and make sure you can kind of tell the difference between these 2 types of inequalities that what we just did. What we have left to do is solve some slightly more complicated problems, but it's going to come back to one of these 2 things every time. So one more time, just repeating some of what I've already said. With less than, you're going to be in between. With greater than, you're going to be going in opposite directions. So less than, between, greater than, opposite. Okay. Let's take a look at some more problems here. Oops, shoot. There we go. Okay. Okay, got it. Sorry about that. All right, so here is number 3. The absolute value of something is less than or equal to 5. Okay, so remember what we just went over. Which type is this? This is a less than type. Now, I know it has an equal sign. That's just going to affect our brackets when we do our final answer. But less than, that means we're going to be between. We'll be setting up our answer in between two endpoints. So between what? All right, let's find out. We're going to be setting up our absolute value. The stuff inside the absolute value, that's going to go in the middle here. So 2x minus 1 over 3. We are now in between 5 and -5, but order absolutely matters. So make sure you've put the -5 first and then the +5. Okay, here we are. So if I have something whose distance is less than or equal to 5, I need to be set up in between -5 and 5. Okay, so again, just the thing we're modeling after right now, I'm just going to rewrite it. If you have the absolute value of x less than or equal to p, that means you're between -p and p. That's what we're dealing with, okay? So that's kind of our guideline. So we've set it up between -5 and 5. What do we do now? Well, now there's something that we need to solve. X is not by itself. This is an actual problem to solve. This is a compound inequality, by the way. Okay, so we've solved these before in the previous lesson. We've also cleared fractions before. So let's go ahead and multiply by this denominator 3. And we're going to do it on all sides. Left, right, and middle. And clear that fraction as soon as possible. Okay, -5 times 3 is -15. I'm working on isolating x right now. I'm just trying to solve for x. The absolute value part of the problem has been taken care of. Now it's just a matter of solving for x. Okay. Oh, I forgot something. I forgot the -1. My bad. Try again. 2x minus 1. There it is. Okay, so here's what happened so far. The absolute value was less than or equal to 5, so we set our problem up in between -5 and 5. Now we're working on solving for x. I cleared the fraction by multiplying by the LCD, the least common denominator, which was 3. And now I'm going to keep going. We're going to continue getting x by itself. I'm going to add 1 because of that -1, and of course I need to do that everywhere. Normally we would say do it on both sides, but in this type of problem, there's kind of 3 sides. There's the middle, there's the right, and there's the left. So just add 1 in all 3 spots to keep everything balanced. Okay, here we go. So 2x is left in the middle there. 15 plus 1 is 16. -15 plus 1 is -14. We're almost done. Our last step to get that x by itself would be to divide by 2. Okay, I'm going to come over here to finish up. -14 divided by 2 is -7. 2x divided by 2 is just x. That was the whole point of why we did that. And then 16 divided by 2 is 8. Now I'm keeping my inequality signs facing the same direction. Sometimes we flip them if we divide by a negative, but in this case, that's not what happened. We just divided by a +2, so they just stay in the same direction. So I have my answer. This is in set notation, depending on the directions, which I didn't really give you right now. But 2 other things we need to be able to do is illustrate our answer on a number line, as you've done many times before now. And we also need to write it in interval notation. So I'm just doing a really rough number line right here, just making sure my endpoints are in order. Okay, x is in between -7 and 8. We do have these equal signs, so we are going to be using those square brackets because of the equal signs. Okay, so x is in between. So there's my number line. And then finally, I get to write my answer in interval notation, square bracket, -7, comma, 8, square bracket. There you go. So I have my answer in this set notation. I have it on a number line. And then finally, we have it as an interval or interval notation. Okay. Very good. I think we might have one more problem to do. This was a more complicated less than or equal to problem. I think the next one will involve greater than. So we'll get to see our answer kind of going in opposite directions. Okay, this is number 4. This time we have an absolute value greater than 12. Okay, so let's remember which type we're dealing with here. If you have the absolute value of x greater than something, what are we going to do? Let's see. This is not the one where we're in between two endpoints. It's the opposite of that. We're going in opposite directions. Okay, so, whoop. Oh, what did I just do? Ah, okay, sorry. Let's go back. Oh man, sorry about that. Okay, what were we doing? All right. Let's see. Absolute value greater than something. What are we saying? Opposite directions. We're not going in between. So let's see. X could be less than negative p, or x could be greater than positive p. This is kind of the model that we're using to solve this one. And when you saw that list of the 4 different kinds of absolute value inequalities, this was one of them. Okay, this is the greater than situation where you're going in opposite directions rather than in between. So we will not be setting this up in between negative 12 and 12, but here's what we will be doing. We will be using negative 12 and 12. It's just that we do need to write it as 2 separate inequalities. Okay, it's one or the other. So one of our inequalities will be 9 minus x is less than negative 12. Shoot. Sorry about that. Eraser. I got a new pen in case you can't tell. It's supposed to make everything easier. We'll see. There you go. So thanks for bearing with me. I think it's okay. Better than writing with my finger. Okay, so we're either less than negative 12 or greater than positive 12. So those are our 2 different situations, our 2 different possibilities. Okay, now we're going to carefully solve for x in each inequality. Now there is a minus x here, so that's going to make things just a little bit complicated, but we'll deal with it. Let's start with the equation on the left. I'm going to subtract 9 on both sides. Negative x is less than, let's see, this is now negative 21. I now need to divide by negative 1 to finish getting x by itself. When I do that, this less than is actually now greater than. So I'm now flipping my inequality. We do that when we divide by a negative. Okay, so just remember that rule. Whenever you divide or multiply by a negative, the direction of your inequality sign flips. Okay, and then negative 21 divided by negative 1, of course, is just positive 21. So this is part of my answer. I'm just going to circle that. We'll need to put it in interval notation, but we'll come back to that. Let's now work on solving the other inequality. Starts off the same way, subtracting 9 on both sides. 12 minus 9 is 3. This time, again, we're dividing by negative 1. Also, again, our direction of our inequality will flip. So the greater than becomes less than. And again, just a reminder, when we divide by a negative, we flip the sign, okay? So that's what's going on here. When you divide by a negative, your inequality sign will flip. Okay, good. Go. Okay, so let's finish this. 3 divided by negative 1, that's negative 3. Here's the second part of our answer. Okay, so x is greater than 21, or x is less than -3. Let's sketch this on a number line. Now we got two answers. They are not really in order though. So it's important on our number line that we put these numbers in the correct order. -3 comes before 21 and 0 somewhere in there. Okay, so for x is greater than 21, let's start with that one. Okay, this way. And we're not including the 21 because there's no equal sign, so we do want round parentheses. That's one part of our answer. The other part of our answer, less than -3. Now we're going in the other direction, in that negative direction. X is less than -3. Going to the left, again, not including the -3, so we have that kind of round parentheses there. These are the two parts that I'm shading on my number line. And the last thing for us to do is write our answer in interval notation. Okay, so from left to right, even though I named my inequalities in a different order when we solved, when we write our answer in interval notation, we absolutely need to name them left to right. So from the left, first thing we see is -∞. And feel free to label that if that helps you. Try to do that. So -∞, comma, -3, parentheses. Then I have that union symbol in between. And then on the right side, parentheses, 21, comma, +∞. And that is your final answer in interval notation. Okay, so just to kind of recap, the reason why we set it up like this is it all came back to the direction of our sign. If your distance is greater than 12, you're either less than -12 or actually greater than 12. Okay, and once again, just be aware the most common mistake for students when solving these is giving one answer instead of two. So just the main idea in all these different problems is you should be getting two parts to your answer. Okay, for greater than, it really is two different intervals with a union in between. For less than, there's still those two endpoints, so you're in between those two endpoints. Okay, good. So I think we've made it. This is the last example in lesson 16. What we covered here is absolute value equations, where you got two answers. And then the harder ones probably were the absolute value inequalities. I know it's a lot to keep track of. I'll just quickly bring us back to that kind of summary slide now that we've seen all these different examples. This is the one you want to come back to probably. Okay, so 4 types of absolute value inequalities. Now that you've seen all 4 types, this is the one you want to come back to refer to. So the less than types, you're in between. The greater than types, you're going in opposite directions. Okay. Good, so I'll end it here. So we're done with lesson 15 and 16. A lot of inequalities stuff still happening. I will say that lesson 17 and 18 are totally different. You might like them better or not, we'll see. What we have left to do, lesson 17, systems of equations. That's really kind of 2 lessons in one. So I'll probably do 2 separate videos for that one. And then lesson 18 will be some word problems, everybody's favorite. So applications of systems. Okay, and our third exam will cover lessons 15, 16, which is what we just did, as well as 17 and 18. Okay, good. Well, I'm ending it here. And as always, let me know if you have any questions, and thank you very much.